Inverses. Let's take a look at this particular function here where f of x is x plus 4. Now, look at the ordered pairs that this particular function produces. Let's see. If I put a 1 in for x, 1 plus 4 is 5. If I put a 2 in for x, 2 plus 4 is 6. If I put a 3 in for x, I get 7. If I put a 4 in for x, I get 8. And that's enough. I'm going to take a look at another function. And this one I'm going to call f with a little -1 looking sign up there. And we'll get to what that exactly means in a minute. But this one's going to be called x minus 4. And if we do the same thing, let's put x's in and see what kind of numbers we get back out. If I put 5 in, 5 minus 4 would be 1. And if I put 6 in, 6 minus 4 is 2. If I put 7 in, I get 3 back. And if I put 8 in, f of 8 is 4. So take a look at the similarity between the sets of ordered pairs. Do you see similarity, Sarah? They're backwards. They've been flipped. What was once x has become y, and what was once y has become x. And if I were to look at the domain and range of f, for domain I have 1, 2, 3, 4, and for the range of f I have, oh, that was ugly, I have 5, 6, 7, and 8. And if I do the same thing for this f minus 1 guy that I have there, if I look at the domain of f, the bottom one, I have 5, 6, 7, and 8. And if I look at the range of the bottom one, I have 1, 2, 3, and 4. So they're backwards. They're opposites of each other. They are inverse functions. That f to the minus 1 means, wow, what was I writing? Oh, f inverse is how that's read. I can make a better f if I try really hard. There. And what is really this inverse thing? Well, now you see it. The x's have become y's and the y's have become s's. That's what an inverse does, is it mixes these things up. It crosses them. The domain of f is the same as the range of f inverse, and the range of f is the same as the domain of f inverse. Just for fun, because you thought we were done with compositions, but we're really not. Let's take the composition of f and f inverse. F is this thing that you put something in and it does this to it. It does that to its input. In this case, the input is f inverse, which is x minus 4. Minus 4 plus 4 is 0, and you get x. Let's do the opposite. Let's do the backwards and go f inverse composed with f. F inverse takes an input and subtracts 4 from it. In this case, that input is x plus 4. 4 minus 4 is 0, and you're left with x. They both give you x. So we have all the information here that we've discovered about inverses we can use and make an actual definition. It's an inverse let's take two functions, f and g, let f and g be any two functions just as long as f composed with g is x and g composed with f is just x. Under these conditions, g is the inverse of f. So that's what an inverse is. An inverse function is a type of function such that when you compose it with f, you get the identity, which is just x. So if you were asked to show that f and g are inverses, you would use the definition and you say, well, if they really are inverses, then f composed with g is going to be just x, and g composed with f is going to be just x. So here is an f. Let's give you 2x cubed minus 1, and here is your g, the cubed root of x plus 1 over 2. Ugly little radical sign there. And show that they're inverses. Well, that happens by taking the composition. If we compose f with g, that means you take f, which takes an input, and it does this to it. And if the input is g of x, then we put g of x in that spot and try to simplify. The cubed root of anything cubed is going to be just that thing. So I'm going to have 2x plus 1 over 2 minus 1. 2's are going to cancel. I have x plus 1 minus 1. That leaves me with just x. And if I do it the opposite way and take g composed with f, g is this thing that does this to an input. And in this case, our input is f of x, and that's going to be 2x cubed minus 1. And then you do your best to simplify. Well, we have minus 1 plus 1, which is just 0. And we have 2 divided by 2, which leaves me with the cubed root of x cubed, which is just x. So f and g are inverses. That's not so horribly bad, is it, Sarah? Is that so bad, Erica? I mean, really, in the big scheme of things. Are you okay, Amelia? Okay. Is Amelia crying? No? What if you weren't given the inverses? What if you had to find the inverse? This could be scary. Let's let f be 5 minus 3x all over 2. And we want to find f inverse. Well, that's a thinker, isn't it, Bartolomeo? Let's go back to the definition of the inverse.